Welcome, ladies and gentlemen, to this small video tutorial on how to set up an automated knee that's very stable, and you don't need to use any custom nodes. It's just constraints and hierarchies within Maya. So you've probably seen typical IK leg setups before, and some attempts on automating the knees, but they're usually not that stable. I've seen one solution before that's very similar to the one I'm going to show you, but it has some disadvantages that it's hard to blend different pole vector directions together. It's only used for automation or not. This one is more flexible. You can mix and however you want with it, and it's easy to remember. I'm going to show you first how it works. So I'm just going to hide my face. You don't need to see that anymore. And so this is a character I'm using that I made myself for Unreal Engine 4 for prototyping purposes. And I'm using this leg setup for this guy. So you can see it's a normal IK, but oh, my voice just broke. But you can see the IK is very stable. No, even if I'm trying to break the leg of this guy, it's still automatic. The automation is based on the direction of the foot, no matter where it is. And let's make him fly. But you can see I can go to extreme positions with this guy without the leg messing up. And you can see I don't have any polevectors, but that's because I don't like working with them. I have a twist attribute on the controller, and I can control the knee like I want. But I'm going to show you how to do this whole setup with the pole vector visible. But we're also going to add an additional behavior to this setup, which I think can be useful for some of you, where instead of just turning off the automated knee so the locate becomes in the world, we can also do it so we can decide how much the pole vector is going to follow the foot versus the pelvis. So when it's off, the pole vector is going to rotate along the direction of the pelvis, so you can have a more organic blend. So for example, in this direction here, maybe the pole vector should be something more like this, because we're going to an extreme angle with the leg, or maybe not that extreme, but we're starting to break the leg, you know. So maybe the knee will fall after, and this is the extra attribute I want to show you. So enough about this guy. I'm going to make an empty scene and a typical leg setup, nothing advanced. You've seen this before if you've rigged a lot of characters. Okay, so I'm going to move this up so it's on the ground, and I'm going to front view. I just want to make two legs so it's easy to visualize what I'm doing here. This is going to be a very doesn't have to be that wide, and I'm going to add a pelvis bone. I'm pressing all over the place. So we'll add a pelvis bone as well. So typical leg setup, and I'm going to add IKs for both. Let's see, am I getting the right IK handle? Rotate plane solver, and going to make an IK for both of these, and make two very simple controllers. Add it. I usually like to add a pivot below the heel, so we have two controllers, and I'm going to, where did my transform go? I'm going to freeze transformations on these two. Constraint parent, and we're going to orient constraint and orient constraint. I'm not going to work more with this right leg. It's only here for visualization. and I'm going to add the pelvis controller as well, so we can control the hip here. Going to freeze transformations, so I can always reset back to where I want it to be. And we're now also going to add the Polevector controller, so add this one here. I'm going to make sure that the knee can't reach out to that location, so we'll add the Polevector. I'm going to freeze transformations on this guy as well. And now for clarity, I'm going to name everything, so left leg or knee Polevector controller. And let's see, that's a pelvis controller, right foot controller. I'm not going to bother about naming them IK, FK, etc. Left foot controller. We're not going to do left foot IK handle. I'm not going to name joints, it's redundant right now. I'm going to just group the right foot so we don't need to see them. And okay, so now we have our classic leg setup with the Polevector. This is most likely what most of you have seen before. So if you can get to this stage, that's perfectly fine. So now let's get down to the actual automated knee setup. What we first need to do is to set a baseline for understanding what we're working with. The automated knee is using an aim vector constraint to keep track of where the foot and the pelvis are. So to make it easy to visualize how everything is oriented, I'm going to make a locator that's going to be our parent to control the Polevector. I usually use an empty group because I know how the setup works, but this is so it's easier for you to see how the relation works. So this is going to be the automated knee pelvis, and I'm going to name this better. Follow pelvis, and then I'm going to do the same with follow foot. And here's where the aim constraint comes into play. A small tip, when you're working with the aim constraints and you need to know which vector you're working with, just use the move tool in object space, because then you can see how each object is oriented, and you can just look at the X, Y, and Z axis on the move widget to know how things are oriented. So in this case, when we're going to do the aim constraint, you'll see our dummy here. I'm going to use the negative y-axis to point at the foot controller, and I'm going to use the x-axis to define the up vector between the pelvis, foot, and the automated knee setup. So for the first aim constraint, I'm going to take the foot controller to the automated knee follow pelvis. This is important on the first one. I'm going to get the option box on the aim constraint, and I'm going to use object rotation up. I want to use a vector on the target to define how to twist this object. So remember, minus y, the negative y-axis, then the x-axis on this dummy, and then the x-axis on the... I'm going to start with the pelvis. So pelvis controller. So it's going to aim down on the foot, but the up axis are going to be on the pelvis. And note, I'm not using maintain offset. We'll see it pop a little bit. Or it didn't. Okay, maybe it's perfectly aligned so we didn't see it. And if I'm going to rotate this now, what did I do wrong? This is perfectly correct. Note, if I move the controller here, you see it doesn't twist. but if I rotate the pelvis, you see it rotates along. I'm going to add a point constraint to this hierarchy because it needs to follow the leg. So now when I do this, you'll see how it follows along. Did I do a faulty IK setup? Let's see the orients on this guy. Ah, yes. Sometimes Maya likes to flip some axis even if you do it on a plane. So we're just going to delete the IK handle for this one quickly. And I'm going to, let's see here, rotate locally, and I'm going to flip this over. So we want the C axis to be in the same direction on all three. Just to make sure it doesn't flip. And let's see here. I think that should be enough. Skeleton, let's see, IK handle tool. And let's redo this. Constraint parent, and we'll take the pole vector, connect that again. Let's see here. We don't have any flipping now, hopefully. So okay, the IK is now stable. So left foot IK handle. We're back to where we were supposed to be. Okay, so our dummy here is following the leg, and it's now oriented in relation to the pelvis. I'm going to do a parent constraint to the pole vector, so it now will follow this hierarchy. So we almost have the whole automated knee. I'm going to add the last aim constraint, which is to follow the foot. So the exact same settings, but we're going to use the left foot controller. Now when I add this, you're going to notice that the whole hierarchy is following the foot and ignoring the pelvis. That's because this child is overriding whatever orientation the parent here has. And this is exactly what we want. Because now I can blend between the foot transform and the pelvis, or rather the foot space and the pelvis space for the automated knee. And that's very simple. What we want to do is key the animation, the automation on this, the one that follows the foot. So now we can turn it on and off. So now it's on, and let's turn it off, and you'll see it will blend between the pelvis and the foot controller. So if I do this 50%, you're going to see that no matter how I orient it, it will always try to be in between the pelvis and the foot controller here. So this is more like what an animator prefers. Maybe they won't like to have this blend, but it's good to have an alternative to be able to turn this on and off. So on the foot controller, I'm only going to add a attribute that is orient to foot. Knee orients to foot. I make it obvious what it's about. Rather a long name than having to guess what it does. So connection editor. We're going to connect this attribute to the blend aim. So now the animator will be able to get this controller and decide where it goes to. And we want to add an extra attribute to this one, which is automated knee, which is essentially having the pole vector following the setup. It's very simple. It's just the to key these ones. For cleanliness, I don't like having the parent constraint on the pole vector itself. I'm going to do it on a group on top of it. So follow automated knee null. yeah, just to it's a really long name, but it's obvious what it does. So I'm going to get this one, re-add, the same parent constraint as before, so it follows our automated setup. But now I don't have any keying values here. It's just for the animator to work with. They shouldn't have to see like the constraint setup. So I'm going to key it. You see the blend parent. We do the connection editor. This is going to be driven by our IK controller, and we do the automated knee. So now we not only have the automated knee setup, so I can control this however I want. It's stable, it follows exactly like I want it to. I can tell it to orient to the pelvis instead, so it will always be in the direction of the pelvis. I can have it 50%, and the best of all is that I can at any time just blend it off and it will follow my pole vector, which is independent in the world. This could be a situation where you, for example, want the character have the knee on the ground and you don't want the knee to slide around. For example, this is a soldier going down on his knee to fire from a crouched position. In that case, you don't want the knee to follow the foot when you're posing it, because otherwise... Okay, let's see. I need to... It seems I'm still having a bit of stability issues with this IK setup. What could it be? How come I suddenly got something? I think this has to do with because these guys don't have any rotation values on them. And where did my pole vector go? Okay, so we have it back. I'm going to try to repost this. I think I just mixed up a few things. Okay, so we have our foot here to show the example. So we have put this guy in a crouched position, and when you're animating this now, you don't want the knee to start rotating along when we're adjusting the foot. So it's much easier to just turn off the automated knee, get our pole vector back down here and have it stationed on the floor, because then the knee will be locked to the ground and we can pose our foot without any flipping. I think the issue before was that I confused myself with the pole vector being in a bad position and it flipped the whole knee setup. It's just a typical IK limitation. But if you keep the pole vector in a stable position away from the hip location, you shouldn't have any problems. So hopefully you can see the usefulness of this setup. And if you're a beginner, this was a very fast tutorial, and I can understand that it is confusing, but I would recommend you learn a basic setup and then try to do the setup I just did. For someone that's used to rigging, you shouldn't have any problem to understand how to set up this setup. It's essentially just a dummy following the hip, which aims at the foot controller, and you can blend it on or off. That's all there is to it. And we also made an extra step to be able to decide if the automated knee should follow the pelvis or the foot. And I think this is like the sweet spot for animators, because you have the best of two worlds. You can have an automated knee and you can have a stationary pole vector, and you can blend between them, and it never flips unless you did some mistakes like I did early on with the wrong orientation of this vector, the orientation. Oh, it still has a look, I still have a horrible leg setup. But if you just do the joint hierarchy properly to have it planar and the basic IK setup properly, This should be completely stable. You should never have a leg that flips in weird situations. So I hope you found this tutorial useful. I would very much like to see the setup used in more character rigs, because I personally love to work with it. It's incredibly fast to animate with, and so please use it in more character rigs. Oh, for the beginners, I forgot one last detail. You know, I had a twist attribute on the leg, so I'm just going to add this as a last detail, so the beginners are not confused where it went. So this is the twist knee. Essentially, I want to be able to control the offset of the knee without touching the pole vector. So we go back to the connection editor, we find our twist knee. Then all I have to do is select the IK handle and connect the twist. That's all you have to do to it. Now I can post this one. We have automated knee on. You can see, and I can add the offset on the twist. If you want to change the direction of this, you have to use custom nodes, but that's not so bad. But I don't think I've forgot anything. This is all you need. This will take you maybe 10-15 minutes to set up when you know how to do it, and you can easily make a script to set up this automated knee. If you use the scripting, you'll be done within an hour. Not even that, I think you can do it in half an hour. Just copy and paste the macros in the log window and clean it up with variables. So I hope you like this tutorial, and I look forward to seeing more rigs with this setup. Thank you for watching.